Hi, good evening. It is October 28th, 2015. This is the Wednesday evening Brown Bag US. Today's presentation is going to be done by Sarah Zelechoski, and the topic is the private islands for rent, an introduction to Amazon VPC. Your presenter this evening, oops, I guess I should actually put this in presentation mode. That would help. Your presenter this afternoon is Sarah Zelechoski. She can be found at @Zelechoski, and her website is www.reactiveops.com. So without further ado, I will switch presentation over to Sarah. And you should now have presentation right, Sarah. There we go.
All right.
I can see your screen now.
Excellent. Good evening, everyone. So I'm going to be experimenting with an analogy tonight. And so I totally expect someone on the internet to pull this apart at some point. But I think we're going to make it work. And I'm going to basically introduce you to Amazon VPC. So without further ado. When I usually meet people and they don't know much about Amazon, and I'm talking to them about the merits of AWS. They always tell me, the first thing they tell me is, I love my data center. I own my own equipment. I have my own private network segment. I control the entire security, and I have physical access to it. I've got a team of support people who can go switch out disks and things. And I've invested a lot in my hardware, my storage. I've hired people who know what they're doing with this type of stuff. And so they're really in love with their data center. And then they tell me, but I've heard that cloud is where I need to be. Cloud is the new hotness. I'm really interested in things like scaling up and scaling down, paying only for things that I use. So if we're running a test, I can spin up a bunch of servers and then, spin them down after I finish. And maybe I can put a data center closer to my customers somewhere else. Or cloud has this huge community around it where I can get scripting and automation and push button stuff, so I don't have to roll my own anymore. And I really like to get rid of that bill that I have for power and bandwidth and old servers that I need to refresh and things like that. And inevitably the conversation comes to this part where we tried AWS a few years ago, but and it's usually, the but is usually, it wasn't what they were looking for, they couldn't get the control they wanted, et cetera, et cetera. So AWS of a few years ago was this, the suburbs. It was EC2 Classic. There was no privacy. Everything was on shared hardware, so you were multi-tenant. All of your servers were virtualized on servers with other people's servers. There was no network segmentation. When you stood up a server, you got an IP address on a private address space, sure, but it was shared with everybody else in EC2 Classic. And all of your servers had a public interface. So if your security was wrong, somebody could access anything. So if you had a database in EC2 Classic, it had a public interface, and somebody could access that. Along with that, the security groups were really inflexible. You only got access to ingress rules, controlling traffic coming in, but you couldn't control your traffic going out. And you were unable to change those rules live without stopping and starting your servers. Furthermore, some instance types were not allowed in EC2 Classic. They didn't have HVM virtualization. They didn't have native VPN connections back to your data center. So if you had a requirement to keep your database in your personal data center, and you wanted to put your servers on AWS, you didn't have a choice to connect the two without rolling your own IPsec tunnel. And all the new hotness for AWS that's coming out now with container service and config and all that, you can't use it with EC2 Classic. So EC2 Classic has gone by the wayside, and it's not even available to new accounts anymore. So if you were to sign up for AWS today, you wouldn't even see EC2 Classic. It's not a thing. So I have great news for you, and that is that VPC is an awesome place to be. And this is where I start my analogy. VPC is like a virtual private island for rent by Amazon. It's your little slice of heaven. It's logically isolated. You have the option of single-tenant hardware if you're worried about it. You have private networking. You have complete control over the infrastructure inside your VPC, subnets, routing tables, all that. You have complete control over the security, network ACLs, security groups, etc. And it's compatible with all the new awesome things that are coming out of AWS. This is just a table of contents of what I'm going to talk about. A lot of them are networking concepts, and that should appeal to a lot of you people who are very familiar with classic networking and data centers. So to continue the analogy, VPC is like a private island. It's self-contained. You can think of it like a data center. You get a 16-bit CIDR of your choosing, and you can build to suit. So you can build a custom subnet structure inside, just as you would if you had access to your Cisco gear in your data center. You would create all the subnets. You could create all the ACLs. You can create custom routing to get your instances talking the way that you want them. You can create custom security. And all of the resources from Amazon, whether it be cache instances, regular EC2 instances, RDS databases, load balancers, whatever, they can all be assigned to this single VPC. This is what a VPC looks like in diagram form. I'm just going to basically show you this as a kind of an intro, because later on in the talk I'll be showing you where all the pieces and parts fit. And if you were in the AWS console, this is what a VPC would look like. You create a VPC, and all it has is a CIDR, a region, a network ACL, which is default, and a default route table. So that leads into the next part, is that the analogy is, well, what ocean is your island going to be in? Well, that's what we call a region in AWS. A region is exactly what it sounds like. It's geographical. It's where in the world is your island. And these are multiple data centers around the world that AWS owns. You can choose to have one close to you. You can choose to have one close to your customers. A lot of people have multiple VPCs in multiple regions. And you should know that some are bigger and more popular than others. So the US has US East 1, which is the biggest and most popular on the East Coast. West Coast has 2, US West 1 and 2. 2 is newer in Oregon, and it actually has more available resources. So these are the types of things you want to keep in mind when you're choosing which ocean that your island should be in. If you're in the console, it will give you the option to look at whatever region you would like to build in. And this is important. If you have multiple VPCs in multiple regions, you have to make sure that you're in the right one. So the next part we're going to talk about is the Internet Gateway. Think of this as the channel out to the ocean from your island. If you need to get out to the Internet, which is the ocean, the wider ocean of the world, you need to go through the channel. All the communication from your VPC goes through the Internet Gateway. You get one Internet Gateway per VPC, that's it. And the public subnets inside your VPC, which we'll talk about later, use this Internet Gateway as their default gateway. So all traffic that is routing outside of the VPC will go directly to the Internet Gateway, while private subnets, which are going to be the more secure inner sanctum of your VPC, will use a NAT instance to forward traffic out through the Internet Gateway. So that's your channel out to the world. And what that looks like on the diagram is this. The Internet Gateway you can see up at the top in red, and the traffic going out to the world from your VPC, which is the teal box. And of course, in the console, this is what it's going to look like. You could create an Internet Gateway, and you'll see there that it is attached to a VPC ID. So it basically specifically attached to a VPC, and you can create multiple Internet Gateways if you have multiple VPCs. So now if we're looking at our island again, the shallows, the part outside of the beach, which is still has content in it, is going to be our public subnet. And this behaves like a classic DMZ, which you would see in a data center. That is, you have instances there with public IPs that are accessible from the outside world, and they can interface at the same time with resources inside. inside the private subnets. And so this public subnet houses all of the ingress points into your VPC. And as such, you should keep in mind that security in the public subnet is tantamount. You need to minimize this footprint as much as possible. And I'm going to go through what lives in the public subnet and what shouldn't live in the public subnet. On the VPC diagram, you'll see here the public subnet in red. I kind of stack the subnets in a certain way to show you that the public subnet is kind of insulated the private subnet from the internet. So it's on top, and you'll see what I have in there right now is very minimal. If you were to look in the console, this public subnet would look like so. It's attached to a specific VPC. It gets a subnet ID. It has a CIDR address that I select from inside my VPC. And that's it. So now, like I said, we're going to talk about what's inside that public subnet. What's in the shallows? So let's talk about the guest cabanas. This is our DMZ. This is where we put instances that need a public interface. Like I said, we have to think long and hard and have a very good reason for these instances. A lot of the time, these are only VPN appliances because the client will have to hit that appliance from the outside. It needs a public address. A bastion host, which is another ingress point into your network, which I'm going to talk about in a little bit. It could be a proxy server. You could have HA proxy that needs to front your application. You could have software load balancers that you roll yourself that need to front your application or data. And those need to have public addresses, but also need to access sensitive data. So they live in kind of this, in between. That is the public subnet. So I talked about bastion host briefly on the last slide. This is kind of a concept that I never saw in my career until I started working with AWS. And a lot of people will talk about it in AWS context without ever explaining what it is. Now, this is not AWS specific. It does exist in other worlds, but it's basically an ingress point. It's an alternative to VPN, and it allows you access from the outside into your internal network. You can imagine if you put all your applications and databases in this private network which doesn't have public access, how are you going to manage them? So basically what you do is you plop a server down, an instance down in your public subnet, and you secure the heck out of it, and you say, my admins can SSH into that, and from there, they've got a command line. They can SSH into other boxes if I give them access. They can run automation tools like Ansible from there if they need to. You can even run Ansible on your local machine and tunnel it through the bastion. And so the bastion host is great because it minimizes the public footprint of your network, right? But it needs strict security. So you need to restrict the ports that are available. You need to sometimes use an alternative port for SSH. And you want to use SSH keys, not username, password. And you want to make sure that your accounts are user-specific. Don't use group accounts on a bastion host. In this analogy, I've made it the HELIPAD because it's like you're flying into your own personal island. You only have access here, so it's special. On the VPC diagram, it looks like this. You can see the bastion host sitting in the public subnet. My admins are contacting it through the internet gateway into the public subnet, and then from there, the traffic flows into all of the internal resources. Now, another thing that exists in the shallows is this arrival jetty. This is where everybody, all of the visitors come to your island. And these visitors may be your customers, and they may want to hit your website. So you need to present them with a public face. Elastic Load Balancer is a service from AWS, and it does a lot of things. It's not just a load balancer, okay? So it is a gateway into your applications and services. You can expose ports 80 and 443 on the front. Actually, you can expose many ports, but those are the most common. And then on the back side, where it talks to your internal network, you can expose different ports. We'll show you in the next slide what I mean by that. ELB can also be an SSL termination point. If you want to have your communication inside your VPC free and open, you can terminate SSL there with your customers. And again, as the name suggests, it is high availability and failover. ELB can determine the healthiness of an instance behind it and failover or direct traffic to other instances depending on the health. This is what an ELB looks like. You've probably seen it already. It's in the public subnet there. And as you can see, the public is accessing it through the internet gateway and it is directing traffic to my application instances sitting in the private subnet. So this is what it would look like in the console. I've made an example ELB here, and you can see where it says load balancer port. Those are the ports on the front in the public subnet. So it has ports 80 and 443 open to the world. And on the back side, I am forwarding all the traffic over HTTP to port 80 on my application instance. And so it's kind of an insulation point between my users and my application. Now the last thing I'm going to talk about that lives in the shallows is this NAT instance. So it's kind of the excursions dock where you would go out for day trips or snorkeling, things like that. You have instances inside your private subnet, and they need to talk to the outside world. We've talked about how you get into them, but we haven't talked about how they get out. So imagine you have your application server sitting in your private subnet, and you need to install something on it. So you apt-get install something, your instance needs to talk to the internet. And I had briefly mentioned before that everything in the private subnet uses NAT. So what happens is you're on your instance, it reaches out to some resource on the internet. What it really does is it's routed traffic to the NAT instance, and the NAT instance then talks to the internet gateway and the internet. So behind the NAT, you have a private IP address, which the world doesn't know about. You talk to the NAT, and the NAT forwards that information, that traffic, to the internet with a public address. And return traffic is permitted that way. This is what it would look like on the diagram. This is a little confusing for people who, when they first look at it, you see we start at the bottom in the private subnet. Our email service and our application instances want to talk out to the internet. So what they do is they go up to the router where the route tables are, and the route table says you live in a private subnet, you need to use the NAT instance. So then the router points the traffic to the NAT instance, and then the NAT instance then routes back out the internet gateway. So now that we've talked about everything in the public subnet, let's talk about the inner sanctum, the private subnet. So this is where all of the good stuff lives. This is where your servers or your instances live. This is where your database lives. This is where maybe your Redis cache lives. Anything really that you don't want to have public access. So instances here only have private addresses. They use NAT to egress to the internet, and the ingress points are either VPN, Bastion, or ELB. And what's cool about the private subnet is that you can control all the security in there. You can do network ACLs so that traffic can only enter the subnet from certain places and certain ports. You can control the security groups around each instance so that only certain instances can speak to other instances. So you really do have a lot of control over the security inside your private subnet. And that's basically the resort that resides on your island. On our diagram, it looks like this in red. You can see it's at the bottom because I like to pretend that it's completely insulated from the internet. And it houses everything. Email service, application instances, we have RDS, that's a database instance, a Redis cache, etc. And this is what it would look like in the console. You can see it's got the same thing as the public subnet. It's got a VPC ID, a CIDR, and it's again got a routing table and a network ACL attached. So let's talk about routing tables. We talked about private subnet, we talked about public subnet, we talked about how they communicate to the outside world. Well, the routing table, which is labeled as the router in the diagrams, is how traffic gets from place to place. So it's basically instructions on how to get somewhere. The concierge on your island telling people how to get to certain attractions. And so each routing table in a VPC has a local route to the VPC. So any traffic within the VPC can get to other instances in the same VPC. And the main difference that we see with routing tables is that we have a public and a private. And this is, as I've described before, the public subnet is attached to the public routing table to use the internet gateway to talk to the internet. And the private subnets are attached to the private routing table to use the NAT to get to the internet. You can have one routing table associated to a subnet, but you can have many subnets attached to the same routing table. And that will make a little bit more sense when I show you what it looks like in the console. So here's a diagram again. I have attached the routing tables to the subnets in the way that they would exist. So the public subnet here has a routing table. As you can see, the VPC CIDR is the first line, and it says local. So all traffic within the VPC is going to be routed properly. And then everything to the world, which is 00000, goes out the internet gateway. Similarly, for the private subnet, we've got the local route, and the world is directed to the NAT instance ID. So what that looks like in the console is this. The first picture we can see is our public primary subnet. And I have the routing table tab open to show you what it looks like. You can see the local route, and you can see the route to the internet gateway. And then the second picture we've got is the private subnet, and you can see it's slightly different. The local route is there, but then the second route, there's some kind of identifier. And that identifier is actually the EC2 instance ID of our NAT. And you can see from the other side, this is the route table in the console. The top picture is the public route table, and you can see the subnet associations. So these are the subnets that are using this routing table. So you can see that I've got my public subnets there. And the bottom is the private routing table, and I've got my private subnets attached there. So let's talk security in this inner sanctum. If you're at the resort, we've got a front gate, and we can choose to let people in that front gate. We can leave it open if we want, or we can close it. Now, in the AWS world, network ACLs are rarely used by the common person. That is because people think security groups are enough. And for the most part, they are. We're going to talk about security groups next. But coming from a data center world, a lot of people are interested in network ACLs. So there's this front gate of your resort. You can control access into any of your subnets. The rules in your network ACL are just like an ACL on your Cisco gear. They're evaluated in order. You can do ingress or egress rules. You've got allows and denies, and they're stateless. So if you have an allow rule and you expect a response to come back, you better have the egress set up properly. So your ingress needs to match your egress. And like I said, this is optional. I don't see it very often. And by default, you get for each subnet you create, it has a default network ACL, and the default is allow all. As you can see here, I have my private subnet, and it has the network ACL, which is default. So since they're read in order, you've got your first rule that allows everything, and then if nothing matches that line, it denies it. So since everything matches allow, all my traffic gets through. This is a more complex network ACL, and I'm not going to go through it in detail because it could get dicey, but you basically see how there's numbered rules. They're read in order. The first, like the traffic that's coming in, the first rule that it matches, it gets passed through. And then if it doesn't match any of the rules, then it gets denied, which is the deny all, which is the last line. So this is a good way to be really strict about traffic coming into your subnets. This is important if you have a VPN and you want to make sure that only certain groups of your VPN can get into certain networks. You can restrict the traffic based on the client coming in. If you have multiple private subnets, say you have dev, staging, test, and production subnets, you could potentially insulate your production subnets with network ATLs. So now we'll talk about security groups. On your private island, you've got all of your guest rooms. Your guest rooms, we're going to pretend, are the instances. They're the individual servers. And each guest room has a door lock. So that's the one thing I want you to take away from security groups, is that they are instance-based. They are applied at the instance as if they were IP tables. And they are associated with a specific network interface. Now in VPC, you can have up to 5 security groups per network interface. And you can add multiple network interfaces in VPC. So you want to build your security groups based on those limitations. Now, what's great about VPC, if you remember when I was talking about EC2 Classic, they only gave you ingress rules. In VPC, you can have ingress and egress, so you can be even more controlling. It's very common that I see people still using only ingress rules and allowing all for egress. But I'm a big fan of egress rules, and I think you can be very strict about the traffic that you allow in and out of instances. If you restrict egress, you can prevent someone, let's say someone's broken into one of your instances and you control your egress, you can stop them from getting into other instances. These security rules can be TCP, UDP, ICMP, whatever you want, and you can specify security group or CIDR restrictions, and these are stateful. So if you allow traffic out to, like, say your application allows traffic out to your database, any response coming back from the database is allowed because the connection was established. So you don't really have to worry about the return traffic like you do with network ACLs. And the other awesome thing about VPC is that you can change security groups live. So your instance is running, you need to change it into a different security group, you can do that on the fly. You need to change the rules in your security group, you can do that on the fly. You don't ever have to take your instances down to change that security, which is awesome. And the last thing that I want to impress upon you with security groups is that I would like you to try to use principle of least privilege. Make sure that people can only do the minimum amount that they need to do work. Make sure that people can only get into what they need to. Now, security groups, I've seen a lot of different types of security groups, and people kind of just write them willy-nilly, but the main 2 groups I've seen are port-based and role-based. Port-based, I've seen people create individual security groups based on what port they would like to open. So in this example, you'll see web HTTP or HTTP world, where they allow ingress on port 80 only, and then they apply that to their instance. Or they create a group called MySQL, and it allows ingress on port 3306, and they apply that to their database. You can stack these, so you can say, like, if I want SSH and web, I can add those 2 security groups to my instance. This gets a little dicey when you want to open a bunch of ports because you see your stack get bigger. And like I said, there are limitations to how many security groups you can put on a network interface. So you can really kind of trip yourself up if you don't think through it too much. The other type of security group is role-based. So this could be, grouping your instances that are similar and opening up the ports that you need to make those work. So the ones that I like to use a lot are presentation, which are ELBs. So for presentation, I only need to open up 80 and 443 ingress, and then 80 and 443 egress to my application servers. Same thing with like my database role. I can open up 3306 from my VPN and from my application, and then I can allow out NTP and ICMP, things like that. So what you really want to do is think about what is the role of this instance. Do I have multiple instances that fit in this role? Then I build up a custom security group to fit those. And here I kind of have an example of one of my application security groups. So I'm looking at the inbound tab, so that's my ingress rules. You can see I'm opening up port 80 to my presentation security group, and I'm opening up port 8000 from my presentation group and 443 from my presentation group. So what this is basically saying is that I am allowing in traffic on 80, 443, and 8000 from my ELBs. And if you look at the egress rules, so I'm now in the application group, and I'm saying, what traffic do I want to send out? I want to send out port 80 to my NAT instance. I want to send out port 5432 to my data instance, and go down the list there. So you can see I have a bunch of NAT rules, which allows me to talk out to the internet, and I have a bunch of data rules, which allows me to talk to my database. So if I go back, my inbound rules is traffic coming from my presentation layer, and my outbound rules are my traffic going to the internet and to my database. So you can see the traffic is very restricted on my application. But wait, there's more. These are advanced topics. So I've covered basically the entire island. But that's not all VPC has to offer. There are more complicated things, obviously, because you can customize everything. I want to cover these topics if we still have time. No, it looks like we're running out of time.
We still have 15 minutes.
Oh, do we? Okay, excellent. So let's try to cover these. So the three that I have in mind are availability zones, advanced subnetting, because right now I've only shown you one public and one private subnet, and VPC peering. So these don't fit into the analogy as well as I would like, but I've tried. Availability zones are the concept that you are going to want to be familiar with if you want to maximize your uptime. Availability zones are isolated locations within a region. So say I'm in US East 1. There are multiple availability zones, A, B, I think C, D, and E in US East 1. And those are all separate data centers. They're all in separate locations, but they're all connected by low latency links. So Amazon will kind of say US East 1, A, B, and C, D, and E, and you'll think they're kind of all in the same data center, but they're not. And the important part about that is that if one availability zone goes down, you can still be up if you also live in another availability zone. So one of the big things that people do with VPC is that they span it across multiple AZs. And as you can imagine, if you have instances in A, B, and C, if you lose A, it's okay because you still have B and C. And what's nice is that all of the AWS services, ELB, RDS, which is their database, Elasticache, which is their Redis and their Memcache, these are all built with magic to span multiple availability zones. So you can build one Elasticache cluster, and it will automatically be able to support multiple availability zones. So this is awesome, right? These are, there we go, the regions. As you can see, US East 1 is the biggest. US West, Oregon, I think, actually has more than 3 now. But I think the default for most people is to try to use 3 for high availability and failover purposes. So I would suggest if you're new with AWS, getting in US East or US West 2, because they have the most availability zones available. This is what a multi-AZ VPC would look like. As you can see, it's similar to our original diagram, but now I have two orange boxes. Box on the left is US East 1A, box on the right is US East 1B. And as you can see, I have resources in both. I have application instances in both, my RDS is in both, my Redis is in both, and my ELB is in both. And so if US East 1A was to fall off the map, I could still run with a minimum setup because I've got ELB, I've got NAT, I've got application, I've got my database and my cache. So the way that this works together is very important. And because there's two availability zones, you have to have two of everything. You have to have two public subnets, you have to have two private subnets, and this all has to be orchestrated very well. So you can see why it's an advanced concept. If you need more information about that after the fact, please feel free to talk to me. Advanced subnetting is another interesting concept. So almost all of the tutorials online that you'll see do the public subnet and the private subnet. A lot of people think that this is fine because they don't need any complexity. Coming from a data center world and coming from a security world, you can imagine cases in which you would want to separate out the subnets into areas of concern. You want to create a subnet if there are different hosts that need to route in a different way, because as you remember, we talked about how each subnet is attached to a routing table. So if you can have a different routing table, you got to have a different subnet. You can use these in fault-tolerant configurations across availability zones, like I talked about, or you can, for some subnets, you may want to turn on that extra network ACL. Some subnets, you might not want to worry about it. So, for example, if you wanted to have your database super secure, you can make a data subnet where your network ACL is super strict, but everything else may not need that. This is a diagram that shows kind of a more complex subnet setup. So you'll see where I used to have two boxes for public and private, I now have a public subnet at the top. In the middle, I have application subnets, and at the bottom, I have database subnets. So I'm abstracting my database subnet even farther away from the internet. This diagram also shows 3 availability zones, and one interesting thing to note is that my last availability zone on the right-hand side only has my public subnet and my database. And that's because I didn't feel the need to split my application across 3, but I did want my database across 3. So those are other custom options that you have when you're making more complex setups. Now, an even more complex setup, which I've done this for a customer, which the security was warranted, is that you have your DMZ public subnet at the top. You've got 3 in the middle, which is infrastructure. So that's like an Ansible server, or a build server, a Jenkins server. Web services, which may be your email instance, your syncing to Google instance, whatever you need, and then your application, and that's like the meat of your project, and you want that separate from everything else. And then at the bottom, you'll see kind of a database layer, database subnet, and a store subnet, which is caching. So in this case, you can see we really wanted to abstract away all of the servers and instances and services into their own subnets so that we can control the security even better. And in this case, we aligned the security groups with the subnets. So where you have an infrastructure subnet, you have an infrastructure security group. Where you have a web services subnet, you have a web services security group. And sometimes it's really nice to be able to align your subnet to your security group so that it's really simple when you're standing up an instance, you know what subnet to apply it to and what security group to apply it to. So this is a really advanced configuration. But it just shows what you can do with VPC. This is something I always like to preach to people when you're doing advanced subnetting in VPC. I'm giving you an entire 16-bit island to work with. don't make 24-bit subnets. That's only 255 addresses, sorry. If you, I mean, you have 65,000 addresses to work with. You can split it up into huge subnets. And that's especially important if you are starting to get into things like auto-scaling groups. Auto-scaling groups is Amazon's concept of, I have a machine image and I want you to spin up as many as possible because my traffic is really high. And as you can imagine, that would eat up IP addresses. As every server boots up, you're losing an IP address. You can have auto-scaling groups you know, in the hundreds and thousands, and you need to make sure you have enough space. So there's no reason not to use it. I've given an example from one of our more advanced subnettings where we're spread across 3 availability zones, and we wanted big subnets. And so here we've set it up so that you can have you know, your public subnets are all contained in the /19 CIDR, and then underneath that they're split up into availability zone 1, 2, and 3, which are all 21 bits. So that's what I would recommend. I've put a link there, which is an amazing blog by an AWS engineer who, you know, originally got me sparked on this idea. Please visit it if you're interested in anything about subnet theory. So there's advanced subnetting. And this is the last topic, if I still have time.
Yep, you're good.
And that is VPC peering. So I kind of hinted at the fact that if you wanted to be multi-region, you had to be multi-VPC. You can be multi-VPC within a region. You can be multi-VPC across regions. The good news about within region is that you can peer them together, which means you can make a communication tunnel between your VPCs within a region. If you spread them across multiple regions, that's not native peering yet. You still have to make an IPsec tunnel. The reason that people do VPC peering, there's 2 main reasons. One is that people would like to separate out their environments completely. So you have one VPC for production, you have one VPC for dev, one for test, one for stage, one for build, and so that allows you to give your staff very specific access. You know, you'd only have access to the dev VPC, or you'd only have access to the stage VPC. And that can isolate your production really well. The problem with that is it gets really complex when you're trying to peer them all together. Amazon makes it sort of nicer because they give you this VPC peering ability where you say add a tunnel between these 2, but you still have to do a lot of custom routing to make traffic talk between the 2 VPCs, and you still have to do security rules across VPCs. Security rules across VPCs are great, except the limitation there is that if you have security group names in one VPC, you can't use those names in the other that's attached to. So if I'm in VPC A and I want to talk, you know, and I'm in the application group and I want to talk to data in VPC B, VPC B is not going to know about your application security group. So it gets rather complex because then you have to start using CIDRs to do security and blah, blah, blah. So VPC peering should only be used in the most advanced of all setups. But I have seen it used successfully by people who want to separate their environments or by people who want to create, I've seen a spoke VPC model, which is a hub VPC in the center, which houses your VPN, your build systems, and your deployment systems. And then you have the environments as your spokes around that hub. And nobody has access to the spokes directly, only to the hub. So that's VPC peering. And it looks a lot like this, where you can have communications between your VPCs. So it's a lot like having a bunch of little data centers. So that's my introduction to VPC, and hopefully the analogy played out as I hoped, and my encouragement would just be to go in there and play with VPC. Don't be afraid of it.
Nice. So I counted 4 pop culture references for anybody else keeping track. Kudos to the Men in Black reference. That was awesome.
Excellent.
That was phenomenal. I know that. So there's one of 2 reasons why we don't have any questions at the end of a wrap up. One is because nobody was paying attention, and the other one was because the presentation was so amazing that you just killed it. And Sarah, you just killed that. That was fantastic. I know that there's going to be people asking for the deck. I don't know if that's private or not.
No.
But if you can email that to me, then I'll be able to put that up on the website.
Absolutely.
And so we don't have any questions. So I'm going to go ahead and stop recording now.
All right.
So
thank you very much, everyone.
Thank you very much. And we're stopping.